Good day to student. Okay, today we're going to look into the transportation in supply chain. Okay, everyone know transportation used to move the product. Okay, so what type of transportation needed by a company? Uh, Manufacturer, distributor to move the product to the end customer. Again, transportation also incur cost. Okay, that cost will be imposed in the product price. So that cost will be paid by the consumer. Okay, objective for this chapter is end of the chapter, student able to understand the role of transportation in supply chain. They are also able to evaluate the strength, weaknesses of different modes of transportation, discuss the role of infrastructure and policies in transportation, identify the relative strength and weaknesses of various transportation network design options, identify trade-off that shippers need to consider when designing a transportation network. Okay, ultimately all the supply chain player along the supply chain, so their intention is to reduce the cost and maximize the profit. Okay, let us look into the role of supply chain, role of transportation in supply chain. Again, simply as mentioned earlier, movement of product from one location to another location. So we know that particular product, rarely produced and consumed in the same location. So it will travel so many places. Okay, and it's of course incur cost, and the cost is a bit significant, not a bit, significant uh, component. Shippers require the movement of the product, carriers move or transport the product. So mode of transportation and their performance characteristic. Here we have seven type of modes transportation: air, package carriers, truck, rail, water, pipeline, and intermodal. So this table shows you the cost that involve using different type of transportation. Okay, and it's depend on the natures of the product. We know there are two type of product. Okay, fast moving and slow moving product. So it's depend on the company to choose the best transportation to transport their product, move their product. So here, okay, when consider air as your transportation mode, the cost component under this category will be fixed infrastructure and equipment, labor and fuel. Variable cost will be the passengers and cargo. Okay, the key issues that need to be considered is location and number of hubs, fleet assignment, maintenance schedules, crew scheduling, price and availability. Okay, package carrier. So talking about package carrier, we have several carriers, service providers, package carrier service provider in local and as well international package carriers. So through them we can send small packages up to about 150 pounds. Okay, quite expensive, but rapid, most of the people using this, and reliable delivery. Small and time sensitive shipment provide other value added services, and consolidation of shipment is a key factor in this uh, mode of transport. Okay, so like for you student, we know Lazada, we know Shopee, we know 11th Street. Most of these online business like giant using package carrier to move their product once you make the order. Okay, so truck, uh, significant fraction of the goods moved. Two type of truckload and less than truckload. Okay, So truckload, low fixed cost, okay, imbalance between flows, and whereas less than truckload is small loads, okay, the quantity that is carried also small. Hub and spoke system and may take longer than truckload. Okay. So rail as a transport to transfer your product or the movement of product, move commodities over large distances. High fixed costs in equipment and facilities, okay, schedules to maximize utilization. Transportation time can be long, trains, boats, not salute, okay, so it will take times, okay. But certain uh, nature of product is suitable when we use rail as a transportation. Water, limited to certain geography areas, ocean, inland waterway system, coastal water, very large load and very low cost, slowest, dominant with global trade, and it's carry containers. Okay. Pipeline is another type of transport modes. High fixed cost, okay, under the water, under the sea, they build the pipeline, everything. So it's really quite expensive. Primarily for crude petroleum, refined petroleum product, natural gas. Best for large and stable flows. Pricing structure encourages use for predictable component of demand. Intermodal, use of more than one mode of transportation to move a shipment. Quite number of companies are using this as their medium to transport their product. Grown considerably with increased use of containers, may be the only option for global trade, more convenient for shippers because it's one entity. Key issues in intermodal is the exchange of information to facilitate transfer between different modes. Transportation infrastructure and policies. Okay, government generally take full responsibility or played a significant role in building and managing infrastructure elements. Okay, without a monopoly, deregulation and market force help create an effective industry structure. Pricing should be reflect the marginal impact of the cost to society. So basically all the transportation infrastructure in Malaysia, especially in Malaysia, is built by government. These are the graphs that explaining about transportation infrastructure and the policies. So you can see the price of trip is on your Paxi Y and vehicle flow rate on your Paxi X. Okay, and from Q quantity demanded whole to quantity demanded 1. So the changes when the movement is there A to B, okay, the point A to B, the movement, yeah, sorry, this is A, the at the point A, okay, Q0 and PO, when they move, they reduce the quantity, okay, then that P point here, so the vehicle flow rate will be reduced, and look at the price is increased. So price of the trip is increased. Okay, so this line is for your average cost time plus operation. This line is for your marginal cost of time and operation. Okay, this is your demand curve. Okay, design option for a transportation network. When designing a transportation network, you should consider several issues, okay, or several issues that should be given a serious attention. One of them is, should transportation be direct or through an intermediate site? Should the intermediate site stock product or only serve as a cross-docking location? Or should each deliver route supply a single destination or multiple destination? So multiple destination is here we call as a milk run. So when you are designing the transportation network, these are the three elements that you need to give a serious attention. So direct shipment network to single destination. So these are the figures, very simple. You see supplier, from supplier is go to buyer location. So a different supplier is good. Okay. So each supplier they use maybe they use similar mode of transportation, but they bear independently they bear the cost of the transportation. So here direct shipping with milk run. You see? So when look at this figure, you see supplier sent to buyer location. From buyer location is go to supplier. Supplier sent to buyer location. From buyer location is go to supplier. Here you see supplier, then this supplier gives to this supplier gives this, then this supplier is transfer to the buyer location. This is called as a milk run. Okay, so by doing this, definitely they will reduce the cost of transportation because it's shared. So all shipment via intermediate distribution center with storage. So you see all the suppliers sent to distribution center, then it's like organized. Then from the distribution center it's go to the buyer location. Much more systemized and easy in a way that information will be flow consistently, and the movement also can be easily tracked. Movement of product can be easily tracked. Okay, all shipment via intermediate transit point with cross docking. Okay, suppliers send their shipment to an intermediate transit point. They are cross docked and sent to buyer location without storing them. So here when talking about cross docking, there is no business of storing the product. The moment the shipment reach the intermediate location, on the spot they will transfer to the needed place. Okay, this is shipping via DC distribution center using milk run. Okay, see this distribution center. So milk run, like buyer also can send their product to distribution center. Okay, tailored network. Okay, this is the network structure. Direct shipping with milk run. All shipment via central DC with inventory storage. All shipment via central DC with cross dock. No inventory storage here. Shipping via DC using milk run and tailored network. So what are the advantage and disadvantage? Of course, when you using direct shipping, no intermediate warehouse, simple to coordinate. High inventory due to large lot of size, significant receiving expenses. Whereas on direct shipping with milk run, lower transportation costs for small lots, lower inventory. Okay, increased coordination, complexity because many people, many parties involved. Okay, in the case network structure or all shipment via central DC with inventory storage, lower inbound transportation costs through consolidation. Okay, but the issue that need to consider is here increase inventory cost, increase handling at DC. So all shipment via central DC with cross dock, low inventory requirement, lower transportation cost through consolidation. This is the plus point of using this network structure. But the minus point will be increase coordination, again complexity. Okay. Shipping via DC using milk run, lower outbound transportation costs for small loads, further increase in coordination complexity. Tailored network, transportation choice best matches needs of individual product and stores, but highest coordination complexity. So actually when you have like complexity, I believe that will increase your cost of transportation. So again, we have to consider the nature of product, and fast moving product need different type of mode of transportation. Slow moving product, different type of mode of transportation. Okay, selecting a transportation network. Okay, again, so there is formula. Okay, there is 8 store and 4 supply sources. So the truck capacity is for 40,000 units. Cost per lot, cost per load is 1,000 US dollar, and 1,000 sorry, US 100 per delivery. Holding cost is 20 cents per year. Okay, so annual sales is 960,000 per store, and we are choosing a direct shipping. Okay, so these are the numbers are given. Okay, so we have like uh, batch size shipped from each supplier, because earlier we already know the truck can load 40,000 unit. Okay, so you take 960,000 divided by 40,000, so you will have roughly 24 number of shipment you need to do. Okay, so annual trucking cost for deliver networks 24 times 1100 times 4 times 8, so you will total cost will be 844,800. Average inventory at each store for each product 40,000 divided by 2, so you will get 20,000 units. So annual inventory cost for direct network, so you take the 20,000 unit times with 0.2 times 4 times 8, then you will get a figure of US dollar 128,000. So total annual cost for direct network, you plus 844,800 plus with 128,000, so all the sum will be 972,800. So this is when you selecting the direct shipping. Okay, now the calculation for milk run. Okay, when you see direct shipping, you got like 972,800 here. Okay, so here for milk run, the total annual cost for direct network is 985,600. Much more higher cost using the milk runs. Okay, because the constraint in milk run network is complexity, coordination in the complexity, because it involves too many parties. Okay, again direct shipping, so you calculate everything. Okay, you just plug in all the numbers and you will get the total annual cost for direct network is 233,600. Okay, but here earlier is 960,000. Okay, earlier example. Now is annual sale is only 120,000 per stock. Okay, so the numbers of annual sales is reduced. You see. Okay, so total annual cost for direct network is 233,600. Using milk run, reduce, you see, 166,400. Look at here. Okay, and also we are talking about the same store, huh? Okay, so here is much more cheaper, the milk runs. uh, okay. Trade-off in transportation design. Okay, transportation and inventory cost trade-off. So that's why I said nature of the product is important. How fast you respond to the customer order is important. So to make that choices, we have to do our trade-off. Okay. So choices of transportation mode and inventory aggregation will be the two main elements when we talk on a trade-off. Transportation cost and responsiveness trade-off. Okay, so that's why I mentioned earlier how fast you want to respond to the customer. Okay, and do the customer willing to pay the high cost for the transportation or not? That also we need to consider as well. Okay, so you see here the mode of transportation. Okay, here they have the cycle inventory, safety inventory, in transit cost, transportation time, transportation cost. Okay, so here you can see the difference between using the different mode of transportation. Based on this, we can make our network design for transportation. Okay, so trade-off when selecting transportation mode. Okay, for example, demand is 120,000 motors. Cost for per motor is 120. Weight will be 10 pounds per motor. Lot size is 3,000. Safety stock is 50 percentage. Okay, so when you using railroad, trucking, freightway, okay, golden freightways. Okay, so the shipping costs that involve per. So if 200 means per, so you calculate lah, 100 7 ringgit 50 cent per, so one shipment or one. Okay, so you just calculate, it's not for the whole unit. Okay, so using the formulas, okay, you get the value for cycle inventory, you get the value for safety inventory, get the value for in transit inventory, and the value for total average inventory. Okay, so then annual holding cost, okay, that also need to be taken into account. Okay, so each, you see, using rail, the holding cost will be 108,900. Here the transportation cost for rail will be 78,000 US dollar. So the total annual cost for inventory plus transportation will be 186,900. You just plus these two figures, okay, to get the total annual cost. So you see, so these are the calculation that so we present it in a table form. So look at the total cost here. Okay, so the highest cost will be on rail. Okay, you see, rail is the total cost is 186,900, but the motor that can ship is 2,000 unit. Okay, but here golden new proposal, they're giving 400, they can move 4,000 unit motors with only expenses of 176,820. So you make the comparison and which is suitable. Okay, then you have to see the safety inventory. Okay, safety inventory. So here is okay, look good. So you have to take into several elements to make a decision which will be your transportation mode. Okay, trade-off when aggregating inventory. So of course there is calculation as presented here. Okay, option A, keep the current structure but replenish inventory once a week rather than once every 4 weeks. Option B, eliminate inventory in the territories, aggregate all inventory in a finished good warehouse at Madison and replenish the warehouse once a week. Okay, all these options to reduce cost and to reduce the inventory as well. Okay, so these are the calculation. So for all 24 territories, IVAL inventory. Okay, so 24 times with 34.7, you will get 832.8 units. Okay, so this all we already look at the previous chapter on safety inventory. How to get these numbers. So I met inventory cost, current scenario, low wall. So here 24 territory, low wall inventory. So 1696.8 unit. Whereas here, when you look, it's only 832.8 unit. Okay. So annual inventory holding cost for IMAC with the formula, given formula. So calculated the inventory holding cost will be 54,366. Okay, so we round it, without rounding, we can put it as 54,395 US dollar. So average weight for each replacement order. Okay, so plug in all the values, then here we get 4 pounds. Shipment cost per replenishment order 0.66 plus 0.26 times 4. Okay, you have to like 0.26 times 4 first, then you plus, so you will get 1 ringgit and 70 cents. So annual transportation cost will be 530 US dollar. So annual inventory and transportation costs at IMAC will be inventory cost plus transportation cost. That will give us 54,896 US dollar. So these are the current scenario. These are the option that earlier, option A and option B. So you see total annual cost. So that's why even though it look cheap, we can minimize the cost here, but again it's depend on the nature of the product. First we want to respond to the consumer, so those elements are very important when you are choosing or making decision. Okay, so trade-off when aggregating inventory. Average weight for each customer order 0.1 times 0.5. Okay, times this first, then plus with 0.04 times 5. Okay, you will get 0.25 pound. Shipping cost per customer order, so you will get 5.53 plus 0.53 times 0.25, so you will get a average of 5 ringgit 5 0.66 US dollar. Number of customer order per territory per week is equal to 4. Total customer order per year. So because it's 4 times 24 times 52. So here the number is wrong. Okay. So the annual transportation cost is equal to 4992 times 5.66. So the total annual transportation cost is 28,255. So you total annual cost is equal to inventory cost plus transportation cost. So you take 28,255 plus here this figure actually total customer uh, 8474, so you will get a sum of 36,729 US dollar. Okay, so transportation cost, demand uncertainty, holding cost, customer order size for aggregate inventory and disaggregate inventory. So transport cost aggregate is low, disaggregate is high. Demand uncertainty, yes, here is high, here disaggregate is low. Holding cost is higher, here will be low. The customer order size large, and here will be small. Okay. Trade-off between transportation cost and responsiveness. So still shipment at TL equal to US 100 ringgit plus 0.01x. Okay, so week 1 and week 2. So you see Monday till Sunday. So these are the still shipment LTL. Okay, presented in this table. Okay, and here day 1, see all data is damn important. Okay, day 1 the demand is 90,970, quantity shipped is 19,970, cost is okay, cost today respond you see so the cost is 299.77, quantity shipped is 0, quantity shipped is 0. Okay, see cost, total cost is 4,164.46. Okay, so here you can see it's like 4-day response. So every 4 days they ship the product. Okay, tailored transportation, the use of different transportation networks and modes based on customer and product characteristic. Factors affecting tailoring. Okay, customer density and distance, customer size, product demand and value. These are the factors that affect the tailored transportation. Tailored transportation continues. Okay, so you see high density, medium density and low density. Distance, short, medium distance and long distance. Okay, so what type of they are giving suggestion, what type of network, transportation network we should advisable to use. Okay, so for product type, high demand product, low demand product. Okay, high demand disaggregate cycle inventory, aggregate safety inventory, inexpensive mode of transportation for replenishing cycle inventory and fast mode when using safety inventory. Disaggregate all inventory and use inexpensive mode of transportation for replenishment. Okay. Low demand here, aggregate all inventory. If needed, use fast mode of transportation for filling customer orders. Aggregate only safety inventory. Use inexpensive mode of transportation for replenishing cycle inventory. So role of IT in transportation. Okay, of course, is the complexity of transportation decision demand using the IT system. IT software can assist in identification of optimal routes by minimizing cost of subject to delivery constraint, optimal fleet utilization, GPS application. So that will ease the process of movement product as well as respond to the customer order. First we are responding to the customer order. Okay, risk management in transportation. What are the risks that need to bear? Three main risks to be considered in transportation are risks that the shipment is delayed, risks of disruption, risks of adverse material. Okay, so how to overcome these risks? So risk mitigation strategies: decrease the probability of disruptions, alternative routing. In case of adverse materials, the use of modified containers, low risk transportation models, modification of physical and chemical property can prove to be very effective. So when making transportation decision in practice, we have to consider a line of transportation strategy with competitive strategies. Okay, consider both in-house and outsourced transportation. Use technology to improve transportation performance. Design flexibility into transportation network. Okay, summary of learning objective. Okay, we are end of this chapter. I assume that you will have difficulty on understanding the calculation part. So practice make you perfect. So I hope that the given exercises on this chapter will help you, guide you to understand more on this chapter. Okay, please do all the exercises and send me your answers so we can have a further discussion on this chapter. Okay, so you should able to understand the role of transportation in supply chain. I assume it's easy for you to understand. Evaluate the strengths and weaknesses of different mode of transportation. So discuss the role of infrastructure and policy in transportation. Identify the relative strength and weaknesses of various transportation network design option and identify trade-off that shippers need to consider when designing a transportation network. Okay, please drop your question in clip platform. Try to do all the exercise, try to understand the chapter, stay at home and be safe. Okay, take care. Thank you.